All right, we'll be looking at problem 11.9 on page 628. It asks us to construct a confidence interval for this random sample of 8 CSB, corn soy blend, some sort of nutritional fortified food that's partially pre-cooked. So we're going to see if this CSB has a certain amount of vitamin C. All right, we're going to use our inference toolbox. That is our state, plan, do, conclude outline. Okay. State, plan, do, conclude. So, state. And we're going to make a confidence interval, so we're simply going to say that. We will construct and we want a 95% interval. We will construct a 95% confidence interval. What parameter are we, mean or proportion? Yes, mean or proportion. It says for mean. We will construct a 95% confidence interval for the mean, and this simply use the words in their statement. Mean vitamin C content of the CSB. Okay. All right. There is our statement. Very easy in the confidence interval. Plan. In plan, we check conditions. Well, previously we've been passing on this, but now we will begin to execute in checking our conditions. We will have 3 conditions that we will check. 1, random. We must employ random chance with either the selection of our sample or if we're conducting an experiment with assignment to groups. Well, this says very clearly that for a random sample of size 8. So I will simply say that stated SRS. It says we've taken a random sample. Okay. It actually doesn't say SRS. It doesn't say simple random sample. I should have used their phrase, but I'm going to say stated SRS. All right. The next condition we will check is for normality. Okay. When we're assessing normality, one of 3 things will transpire. 1, it will say the population is normal. Not the case here. 2, if our sample size is large, let's say 25 or greater, we will employ the central limit theorem. This is a small sample. In the case that it's a small sample, we will look at a picture of the sample. A histogram, a dot plot, many tools we could use. Although it's not the best tool, we're going to use a box plot because it's kind of easy to interpret and our calculator draws it. So at this time we will enter our data and construct a box plot. So we've drawn our box plot, and the box plot looks fairly symmetric. We're going to sketch that. Here is our box plot. Okay, if you need to recall how to draw the box plot, you just enter in your data and you come to menu, plot type 1, box plot is 2. Alright, so now we're going to draw this box plot in there. We've said previously that it's very important to label our plot. Well, there's going to be an exception. With regards to our inference toolbox, since we have to say so many things, they're going to let us get away with not having showing a lot here. So I'm going to draw my box plot, and then I'm going to state that the box plot shows approximate symmetry with no outliers. Normality, condition, reasonable, satisfied, met. All right. Number swing. Okay, do. We're going to actually construct our interval here. We're going to reference our formula chart. Okay, going to the formula chart, it says that the confidence interval is some statistic plus or minus a critical value times a standard deviation of the stat. Do you have a formula chart? As soon as you get to 2 sample, you're going to introduce the calculator. All right, we'll keep doing this by hand stuff until that time. Okay, confidence interval. Here I am again looking at the formula chart. You need to have this at all times. Confidence interval is the stat plus or minus the critical value standard deviation of the stat. Well, the critical value previously it was our z star. Now we're the t distribution, it'll be t star. Standard deviation of the stat. We're talking about sample mean. Here is our standard deviation, but we're going to replace the population sigma with the sample s divided by the square root of n. So here we go. Our statistic, we're talking about mean. Our statistic is x bar plus or minus. Our critical value is our t star, we say. The standard deviation of the stat is the sample standard deviation divided by the square root of n. So we went from the words on the formula chart to the symbology. Now let's come with these values. Well, one variable stats. So I'm going back to my control left arrow, goes back to my data. Then menu, 4 for statistics, stat calculations, 1 variable stats. I go with all the defaults there. X bar is 22.5. Standard deviation is 7.19. I'm going to call that about 7.2. Now let's stick with 7.19, and that'll get it. X bar, 22.5. Plus or minus. We need the t star, so now we're going to go to the table, all right, from the back of the book or from your, and we have a sample of size 8. Here's our t table. Since we have a sample of size 8, we will use 7 degrees of freedom, and we will go until we hit 95%. 7 degrees of freedom, that is 2.365. Notice that number is larger than our 1.96 from before because the t distribution is more variable. $2.365. Our standard deviation, 7.19, and it's the square root of 8 in this case. Alright, so a little calculator work over here. 2.365 times 7.19 divide by 6.01. Okay, 22.5 plus or minus 6. All right, this number here, 6, is called the margin of error, and this makes perfect sense. this critical value times the standard. I didn't mean to scratch out stat there. This is called the margin of error. Margin of error. It's how much we're willing to miss on both sides of our mean. This is a perfectly good way to write this, or we can find this sum of difference. 22.5 minus 6 is 16.5. 22.5 plus 6 is 28.5. You can see that the width of this interval is 2 times this number. 28.5 minus 16.5 would be 12, twice that number. These are equivalent statements for our confidence interval. All right. Lastly, conclude. One more thing we should write in the do statement is what this particular interval was. This is a one sample. We only had one sample t interval. When we make this statement of the t statistic, and we previously said it's a confidence interval, we've implied that, but we'll go ahead and state what we're looking at here. Now we make our conclusion. We are 95% confident the true mean vitamin C content lies in 16.5, 28.5. All right, and our unit, what was the unit here? Milligrams per 100 grams. Okay. Now, part C says the specifications for the CSB states the mixture should produce a mean that is 40 milligrams per 100. Does the CSB produced in this production run conform to the specifications? Perform a significance test to answer this question. Well, instead of performing the test, we're just going to use this particular interval. Let's make our statement, and then we can go straight to the conclusion. So keep in mind that our interval is 16.5 to 28.5. All right. We are looking at now part C. Let's make a statement. State. All right. Our H naught, our null hypothesis, is that the mean is 40. And our HA, we're going to use the mean is different than 40, because presumably having too much vitamin C might be an issue too. All right, it doesn't say we want above or below. But mainly we're looking for at not equal to here, because we're going to use our confidence interval. And remember, a confidence interval is analogous to a not equal to statement here. Okay. All right, and we will define what mu is. Mu is the mean vitamin C content for CSB measured in milligrams per 100 gram. Okay. and we're going to use an alpha that is 1 minus our confidence level here. So our alpha in this case will be 0.05. All right. So now plan, we've already checked the conditions. We don't have to do that again. We're simply going to use this interval, and so we can just skip straight to our conclusion. Conclude. Since our interval 16.5, 28.5 does not contain 40, we reject H naught. The data suggests, now I'll say something in context about HA. I'm just going to replace this HA statement with the context. The data suggests mu, which is mean. The data suggests the mean vitamin C content not equal to, the mean vitamin C content is not equal to and the interval is very compelling about that. We're nowhere near 40. We're from 16.5 to 28.5. So our data definitely suggests the mean is not 40.